Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 19, 2025, about 3 days ago. The striking claim is that episodic retrieval, essentially recalling concrete past experiences into context, unlocks latent learning so models can reuse information that parametric training alone fails to generalize. The paper is titled, Latent Learning. Episodic memory complements parametric learning by enabling flexible reuse of experiences. And the implications for model training are quite significant. In brief, the work ties failures like the reversal curse to missing latent learning, and shows that adding retrieved experiences, paired with an example in context learning, leads to broad gains across controlled benchmarks and navigation tasks. Alright, the previous segment outlined the core claim about episodic retrieval aiding latent learning. Figure 1 presents the concept. Panel A illustrates the reversal curse, where a model answers forward queries but fails on reversed ones unless relevant context is provided. Panel B generalizes this to multi-hop, alternative goals, and cross-lingual cases. Panel C depicts episodic memory retrieving concrete experiences, which supply in context information so the model can flexibly reuse latent facts. While Figure 2 introduces the 4 benchmarks that ground the claims. Panel A depicts codebooks, which test whether models reuse latent indices that were only defined but never used. Panel B focuses on simple reversals, where the answer requires flipping trained relations. Panel C expands to semantic structure like syllogisms and category-based holdouts. Panel D shows the latent grid world, where agents must navigate to frequently seen objects that were never training goals, so success depends on reusing past experience. Alright, the previous figure introduced the benchmarks and what success requires. Figure 3 presents baseline results, which show high accuracy on the ingredients, but near zero on the latent tests. The left panel covers codebooks, where the model recalls definitions and solves prompts when the definition is in context, yet fails when the novel index must be inferred without context. The right panel shows simple reversals, where forward facts and in-context reversals work, but reverse queries without context collapse. So, the previous figure showed baseline models collapsing on latent tests, despite doing fine on ingredients. Figure 4 shows that oracle retrieval changes that pattern because retrieved episodes place the missing facts into context. The left panel, codebooks, keeps near perfect accuracy on definition, recall, and trained indices, and retrieval uniquely lifts latent encoding above chance. The right panel, simple reversals, again keeps forward accuracy high, while retrieval unlocks reverse queries that lacked context. These gains support the claim that episodic retrieval enables flexible reuse. So, the previous figure showed retrieval boosting latent performance. Figure 7 now tests whether in context learning during training is necessary for those gains. The panels show that models given retrieval but no in context learning sequences perform near ceiling on validation conditions, yet collapse on the latent tests, which drop to around 6 to 12%. The grid world panel mirrors this pattern, where success on trained objects stays high, but success on latent objects falls sharply with an episode in context learning. Okay, the previous figure tested the need for in-context learning during training. Figure 6 shows grid world success rates, comparing a baseline to an agent with oracle retrieval. The left panel, BC, shows high validation success on trained objects for both, while retrieval lifts latent object success substantially. The right panel, RL, shows the same pattern, with retrieval tripling or more the latent success, though absolute levels remain far below validation because the agent still must explore. Alright, the previous figure showed retrieval benefits in grid world. Table 1 summarizes the supervised training setup across tasks, which matters because capacity and context length shape how much retrieved episodes can help. Codebooks used a higher sequence length with retrieval at 2048, while simple reversals used 128, and semantic structure in Grid World BC used 1024 and 4096 respectively. Learning rates and batch sizes varied per task, so the comparisons focus on retrieval effects rather than identical optimization. Wrapping up, 2 takeaways stand out. Episodic retrieval places concrete past experiences back into context, which unlocks latent learning that parametric training alone misses, and within example in context, learning during training is critical so models learn to use what they retrieve. The broader implication is clear. Adding effective memory systems could make AI far more flexibly general. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.